Today we're going to be going over 9.2 theoretical probability. I will be giving you your key ideas and going over a couple of examples that will help you with your homework. So take your notes that you'll be able to use on your test, and we'll go ahead and get started. So the main key idea for this lesson is when all possible outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So the probability of an event is written as P with the event in parentheses. So it's written here, P, the event in parentheses, equals, and then here's your ratio. The number of favorable outcomes over the number of possible outcomes. Okay, and that is theoretical probability. So we are going to look at our first example. And our first example has us finding a theoretical probability. So it says you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So we've got these letters over here, E, X, L, O, P, R, and another E. So remember, P, the event, equals the number of favorable outcomes to the number of possible outcomes. So P, we're looking for vowels, and our ratio is going to be 3 to 7. 3, so that's the number of vowels. 7, that is the total number of letters. So the probability of choosing a vowel is 3 to 7, or about 43%. And that's how you find a theoretical probability. You're just doing these ratios like we did earlier in the year. So as long as you remember how to do the ratios, this is going to be relatively easy. All right, and then we're going to look at another example. This time we're going to be using a theoretical probability. So this question asks us the theoretical probability of you randomly choosing a green marble from a bag is 3 to 8. There are 40 marbles in the bag. How many are green? Okay, so we have P green is the number of green marbles to the total number of marbles. Okay, so our ratio is 3 to 8. We're going to make a proportion. Okay, remember how to do those proportions. So our first ratio is 3 to 8, and we want to figure out how many are green when the total is 40. So you make your proportion 3 to 8 equals n to 40. And then you're just going to do that cross multiplication. 3 times 40 is 120. 8 times n is 8n. So 120 equals 8n. We want that n by itself, so we're going to divide both sides by 8. And so our n equals 15. So that tells us that there are 15 green marbles in the bag. And that's how you use theoretical probability to solve a problem. We also have another key idea that we'll be looking at, and this key idea is an experiment is fair if all of its possible outcomes are equally likely. So we have two spinners here. Our first spinner has 4 sections, 2 are 1s, 2 are 2s. So this spinner is equally likely to land on 1 or 2, and so this spinner is fair. Our second spinner has 1, 2, and 3, but our 1 section is a lot bigger than our 2 and our 3. So the spinner is more likely to land on 1 than on either 2 or 3, and so the spinner is not fair. So if you were playing a game, you would want a spinner that looks like this, not like this. And we're going to look at that key idea of fairness in our last example, making a prediction. So we have a spinner here that has 2 sections of green, 2 sections of blue, and 2 sections of red. 2 blue, 2 green, 2 red. And we have scoring rules. So you and a friend are playing this game. So you get 1 point if the spinner lands on blue or green. Your friend gets 1 point if the spinner lands on red. And the first person to get to 10 points wins. Okay? So our question has 3 parts. You and a friend play the game. Is the spinner fair? And that's question A. Question B asks, is the game fair? And then question C wants us to predict the number of turns it will take you to win. So if we look at our spinner, we've got 2 blue, 2 green, and 2 red. So it is equally likely to land on each of the colors. And so yes, the spinner is fair because it is equally likely to land on red, green, or blue. B is asking, is the game fair? So we take our theoretical probability and we look for those probabilities. So for you, P is blue or green, and that is, there's 6 sections of our spinner. So blue or green gives you 4 sections, our total sections is 6, and so that ratio is 2 to 3 once you reduce it. Your friend has a probability landing on the red, so red to the total sections, that's 2 to 6, and so when you reduce that, it's going to be 1 to 3. So it is more likely for the spinner to land on blue or green than red, and so the game is not fair. And then we're going to look at the letter C. Letter C wants us to predict the number of turns it will take you to win the game. Okay, so we look at C. Here we go. So C, we're going to take that 2 to 3 ratio, and we want to figure out how many times it will take you to get to 10 points, because that's your total to win. You win when you get to 10 points. So X is representing how many times it will take you. So you've got your ratio 2 to 3 times your X is going to equal 10. So we want to get X by itself because we want to figure out how many times it's going to take you to win. And so we multiply both sides by 3 over 2. So remember, this is multiplying, and so you want to divide. When you divide a fraction, you multiply by its reciprocal. So we're multiplying 2 over 3 by 3 over 2. So multiply both sides by 3 over 2. So 10 over 1 times 3 over 2 gives us a 30 over 2, which equals 15. So X is 15. So you can make the prediction that it will take you 15 turns to win the game. And that is theoretical probability. So make sure you do your on your own questions. We will go over those in class tomorrow. So please have them done and ready to go at the beginning of class. We'll go over those questions, and then you'll have time in class to work on your assignment and ask any questions that you have. I will see you in class tomorrow.